Welcome everyone to another mathematics session. O'Neill MacLeod is the name, and today we will be looking at standard form. We will, at the end of the class, learn how to write numbers in standard form and why do we use standard form to write numbers. Now, in the world of science, there are numbers that scientists will have to record on a daily basis. For example, the number of cells in a human body is estimated to be just about 60 million cells in the human body. Now, for a scientist to actually write down a number that large, then it is going to be very, very tedious for them to be writing that number on a regular basis. Hence, the reason for standard form. Now, today, you're going to learn what really is standard form and how we go about writing a number in standard form. Now, as was mentioned before, that standard form is just a form, just a way to write very large numbers and very small numbers. But in the world of mathematics, we realize that standard form can be used to write just about any number. And that is what we're going to be looking at today. Now, when we talk about standard form, we also refer to standard form as scientific notation. So these terms are used interchangeably. So if you see scientific notation, it is still standard form. Now, when we talk about standard form is written as a times 10 to the n power. A times 10 to the n power. Now, a is a number that lies between 1 and 10. A is a number that lies between 1 and 10, while n is an integer. N is an integer. And from maybe first form, second form, you'll have learned about integers. We talk about positive and negative whole numbers, including 0, because 0 is neither negative nor positive. It's just 0. So when you talk about integers, you're referring to positive whole numbers, negative whole numbers, or 0. Now, before we even get into this aspect of it, we're going to just recap some things that you would have learned maybe in primary school, maybe in first form, so forth. Now, here, if I should write, say, 3.5 times 10. 3.5 times 10. Now, I would have seen over my years of teaching where students say that, okay, if you're multiplying by 10, then you would move the decimal point and then you would end up with 35. Now, the question is, can we really move the decimal point? Can the decimal point really moving all over the place? Well, the decimal point is fixed. The decimal point is fixed. It really can't move. Decimal point really don't move. It is the digits that we move around the decimal point. Now, notice here that even though maybe you would have learned it that you can move the decimal point, and you would have seen it somewhere, it's just an easy way for you to better understand what you're actually doing. It's not necessarily correct when you're moving the decimal point. Now, what is happening here? Now, if I have the number 3.5, I have the number here, 3.5, and you're multiplying it by 10, what we're actually saying is that each digit here becomes 10 times larger. Each digit here becomes 10 times larger. Now, To my top right here, I have a place value shifting chart. A place value shifting chart. If you notice here, this would have been 7,425.83. 7,425.83. Now, let us say that you want to multiply this number by 10. If you want to multiply that number by 10. Now, based on this that I explained to you, where students tend to use that with an arrow showing that you're moving the decimal point, let's try it with that. Now, if I use my arrow here and put it there, if I use my arrow and put it there, the decimal point you would say it falls somewhere here. But notice what happens. If you now put the decimal point here, then the 8 would still be in the 10th position. The 5 would still be in the 1's position. The 2 would be in the 10th position. The 4 would be in the 100th position. And the 7 would be still in the 1000 position. So by moving the decimal point as you would see it before, it's not really true. All right? That's not true. It's not correct to do it that way. No, here, what we're actually, this number by 10, each digit becomes 10 times larger. Each digit becomes 10 times larger. So here we have 100. If I multiply the 100, the 300 by 10, then that would become 310. I could easily shift my place value chart here. I could shift my place value chart and notice what happened. By multiplying it by 10 here, there is no longer 300, but it becomes now 310. If I multiply by another 10, then the 310 becomes 3 ones, and it keeps on going like that. So each digit would become 10. Likewise, if I decide to divide this number here by 10, each digit up here becomes 10 times smaller. Each digit becomes 10 times smaller. As we say, we're not moving the decimal point. It is the digits that we're actually moving around the decimal point. So here, I will now move my place value chart, and notice here position. It is now in the 1000th position, while the 5 that was in the 1s is now in the 10th position. So each digit here becomes 10 times smaller. All right. Now keep that in mind, because when you're talking about standard form, we will be moving the digits all over. We'll be moving the digits all over. So we want to keep that in mind. Now, here we're saying that if we're given a number to write in standard form, this is how we actually write a number in standard form. A number, which is A representing A, multiply by 10 to the n power. So it's a number being multiplied by the power of 10. A number being multiplied by the power of 10. But this number, we say that it must, the number that we place here must be between 1 and 10. So let's look at this. If I should give you, say, 354.6, and I want to arrange this number so that it is between 1 and 10. Now notice here, for that to happen, then the decimal point will have to be between the 5 and the 3. The decimal point will have to be between the 5 and the 3. No, we're not going to be moving the decimal point. What we're going to be doing is that we're going to be moving the digit. Therefore, we have to move this digit out. Good. So we're going to move it 2 places out. So that will go 1, 2. This one will go 2 places there. And then this will go 2 places there. That's what we're actually doing when it comes on to standard form and arranging the number so that it is now in the ones place. Now this, which is the 3, will now move 2 places to take the place of the 4. So because we move each of them 2 places, now we can now rewrite the number as 3.546. So we move each digit 4 places. So we arrange the number now that it is between 1 and 10. Now, remember I said to you that standard form is just a simple way to write very large numbers or very small numbers. Now, when I look at 354.6, I'm rearranging the number so that I can write it in standard form. Here, this would not be the same as what is up here. This would not be the same as what is up here. Therefore, this number that I just rearranged, it is just the value of A. Now, I need to now multiply that number by the power of 10. Now, notice here, if I multiply this number by 10, it will increase the value of each of these digits 10 times. It simply means that the 5 will become ones or units, 100 will become 10, and the 1,000 will become 100. But that's not what we want. All right, we need to get back to this. In order to get back to this, we must multiply this number by 100. Now, from the last time, we looked at laws of indices, and we know that 100 can be represented as 10 squared. 100 can be represented as 10 squared. So notice here, if I multiply 3 by 100, it now becomes 300. It falls in the 100 position. If I multiply the 10th, which is 5/10, by 100, then it falls in the 10th position. And if I multiply the 100, which is 400, by 100, it now goes back into the unit position. So here we would have written this number in standard form. We would have written this number in standard form. Now notice here, we know how to arrange the number so that it is between 1 and 10. We know how to arrange that number so that it is between 1 and 10. Now, let me kind of help you with that. When you're arranging the number so that it lies between 1 and 10, the first non-zero digit must be in the unit position. So the 3 is the first non-zero digit here. Therefore, it should be in the unit position. So I would move it 1, 2. Remember, we look at how we move all of those digits around the decimal point. So we would move it 1, 2. It's now in the unit position. Now, the value of n. How do we determine the value of n? Now, the value of n is determined by the number of times you actually move the digit. What we did here was to move each digit 2 times. So n becomes 2. N becomes 2. Now, apart, there's something else that you need to understand. If the given number, for example, that would have been your given number. If the given number is greater than 10, if the given number is greater than 10, then n will always be positive. If the given number, the number that they give you to write in standard form, if it is greater than 10, then n is always going to be positive. All right, so let us look at some examples now as it relates to the positive index, as it relates to the positive index. So I'll clean this part. Here we go. If I should give you a number, say 6, 5, 4, 3, 2.67, and I want to write this number in standard form. I want to write this number in standard form. Now, here, the first non-zero digit that we're dealing with would have been the 6. It's now 6. Now, the question is, in order for the 6 to be in the unit position, in the ones position, where should the decimal point be? Yes, the decimal point should be between the 6 and the 5. The decimal point should be between the 6 and the 5. Now, what we're going to do now is just imagine moving all of the digits out of their position. So we're going to move the 6, and I'm moving it 1, 2, 3, 4 times. I would have to move the 6 4 times to get it in the unit position. All the other digits would have moved out of their position 4 times in order for us to move the 6 into that position. Now notice here, I can now write it as 6.5432267. Now notice now, this number, which is A, is now between 1 and 10. But what we're saying, we're not going to change the value of the number. It should be the same thing that we write down here. However, we're just writing it in standard form. So this now becomes times 10. Now what would be the power of 10? Yes, you're correct. 4, because we actually move the digit 4 times. So it's now 1, 2, 3, 4. So this now would have been 4. So yes, you're correct there. So let's try another and see how well we do with that. Let's say I give you 8.54. Let's say I give you 8.54, and I want you to write that number in standard form. Now, what is it that you notice about this number? You're correct. This number is already between 1 and 10. The number is already between 1 and 10. So we didn't have to move any digit to organize the number, to arrange the number so that it is between 1 and 10. We didn't have to do that. Now, how do we write this number now in standard form? Now, we can go back and write down this number that represents A, because A lies between 1 and 10. Now, this will be multiplied by 10, but notice here, the value of n is determined by the number of times you actually move the digit, the number of times you move the digit, so that the number is between 1 and 10. Now, did we actually move any digit here so that the 8 is now in the 1 space? No, we didn't do that. Therefore, since we didn't do it, what would be the value of n? Correct. The value of n would have been 0. Now, if we go back to laws of indices. We looked at laws of indices in the last class. Remember, we say that any number raised to the power of 0, except for 0, any number except for 0, raised to the power of 0, all of that is equal to 1. Therefore, this here is like 8.54 times 1, which is the same thing as 8.54. And please remember, 1 is your multiplicative identity. When you use 1 to multiply a number, you get back the number. It won't change anything whatsoever. So this number that we have here is also the same number that is down here. But now we just write it in standard form. Okay, hope you understand that, because we need now to move to look when n is now negative. We're going to look at n when n is negative. Now, if I should give you, say, a number such as 0.000354. Now, this would be a very small number. That would be a very small number. All right. Now, we want to write this number in standard form. Now, remember, we said that the first non-zero digit that is going from left to right, the first non-zero digit, when you're going to write it in standard form, the first non-zero digit must be in the ones position. So what's my first non-zero digit going from left to right? It's 3. Where is my unit or my ones position? It's way over here. So we want to get this 3 into this position. That's the first thing that we have to do when you're going to write the number in standard form. Now, in order for us to get the 3 here, let's check to see how many places we would have to now move. So I would move 1, 2, 3, 4, 5. So that would be 5 places. So I would move the 3 here. And again, you know that the 5 would move up here and the 4 would move just the same. So we would move 5 places. So it becomes 3.54 times 10. Now, what would be the power now? What would be the power? Now, if you say the power is 5, we might be in a little bit of problem here, because when you look at 3.54, 3.54 is much larger than this number. It's much larger than that number. And if we should go and multiply this number by 10 to the 5th power, this number is going to get much larger. Therefore, in order for us to get back this number to what it is up here, then this now would have been negative. But why negative? Let's think about it. When we look at the place value shifting chart there, we say that when we multiply a number by 10, it becomes 10 times larger. If we multiply a number by 100, each digit becomes 100 times larger. Now, how do we get the numbers or the digit to be 10 times smaller? We had to divide by 10. So if we divide by 10, each digit becomes 10 times. So here, we're not going to be multiplying by 10 to the 5th power. What we'll be doing really is dividing by 10 to the 5th power. Now, from laws of indices, you should remember that 10 to the negative 5 would be the same thing as dividing by 10 to the 5th. Because I could go a little bit further to explain that this could be 3.54 times Now, if I want to change the negative index to a positive one, I would now reciprocate. Remember, we learned that from laws of indices. So this would end up to be 1 over 10 to the fifth power. So in truth and in fact, when you see the negative index there, all it is saying to us, we are dividing. So 10 to the negative 5 is the same thing as dividing 10 to the 5. So again, let me just go over this part here. 3.54 times 10 to the negative 5. Because there's a negative index here, what this is saying is that 3.54 is being divided by 10 to the fifth power. Now, if I divide 3.54 by 10 to the fifth power, it will take me back right here. It will take me back right there. Now, what do we notice in this case? What do we notice in this case? In this case, the number that we were actually given, the given number here, it was not larger than 10. It's not larger than 10. It didn't lie between 1 and 10. This number is smaller than 1. This number is smaller than 1. So what we're actually saying here, if you're given a very small number, a number that is smaller than 1, and you want to write it in standard form, then the index here, the power of 10 will be a negative power. The power of 10 will be a negative power. So let's recap. If the given number is greater than 10, then n will be positive. A must be a number that lies between 1 and 10. A is a number that lies between 1 and 10. Good. Now, the number of times you move the digit in order to get the number to be between 1 and 10, then that would indicate what n is, the power here. So we have a few minutes, so just let's look at a few questions as it relates to the 3 different scenarios that we actually look at. All right, so let's look at these 3 questions. If you were asked to write these in standard form, now you're looking at this number. The first thing you're going to say to yourself, that this number here is greater than 10. So what is it that we know about the power of 10 as it relates to this number? That power must be positive. So we know that for sure. Now, when I look at that now, notice here, the first non-zero digit is 6. And the 6 here should be in the ones position, the unique position, in order for us to write it in standard form. Now here, this is where the unique position is. Now you might be asking, where is that decimal point? Now, with a whole number like this, decimal point would be there. It's an imaginary decimal point. Good, so you're not seeing it, but you must know it is right after the ones position. Now to write that in standard form, I am going to move this 6, 1, 2, 3, 4, 5 times. So I will get 6.7. You don't need to write the zeros in this case. So I can just write down times 10 to the fifth power, times 10 to the fifth power. Now, let's look at this one. We might not be able to work these out, so just let's recap. What do you know about this number? the number is larger than 10. So the power of n, the power, which is n, is going to be positive. Good. What about this one? This number is now smaller than 1. What do we know about the power, the value of n? In this case, the value of n is going to be negative. Now, this is where we'll have to stop. I hope you would have learned something as it relates to standard form. The next time around, we could spend a little bit more time to see how we could rewrite a number, write a number that is in standard form in the normal form. I know you can actually go ahead on your own and try to figure that out, how we could move from standard form back to the normal form. So until then, I wish for you a wonderful rest of the day.